We're going to solve exponential equations. They have variables as exponents. I have 17 previous videos that are linked in this description for Chapter 12 if you need them. The intensity of an earthquake, the loudness of a sound, and the compound interest on a loan, those are all applications of exponential and logarithmic equations. An equation that has variables in exponents is an exponential equation. We can solve these equations by taking logarithms of both sides. You take the logs of both sides, and then we use the log of a power theorem that we discussed in video 12.4b. So let me remind you of that really quick. Let's go up over here. We've got this theorem, log of a power for any positive number x, any number p, that's the exponent, and that base a is greater than 0 and it doesn't equal a 1. Then we have log base a of x to the p power. We put that p in front and multiply it to log base a of x. Okay? So keep that in mind. So it says to solve 3 to the x equals 8. I'm going to take the log of both sides. And if you remember from video 12.5a and 12.5b, we learned that log base m is the same thing as log base 10 of m. All right? So we've got log 3 to the x equals log 8. Using that log of a power theorem, we're going to take that exponent and put it in the front and multiply it. We can isolate this x by dividing both sides by this log 3. That creates a 1, doesn't it? Same numerator and denominator. So now we just have x equals a quotient of log 8 and log 3. We can either use a common logarithm table to look up log 8 and log 3, or we can just use our calculators and type in, you hit the log key and an 8, and then you hit the log key and a 3 to get each of these. All right, you hit log 8, it'll give you this. You round it to the 4 important place values. You hit log 3, you get this. You round it to the 4 important place values. Fractions are little division problems, aren't they? So we're going to divide this. So just put 0.9031 divided by 0.4771, and we get a long, nice decimal. We're going to round it to the important 4 place values, and we get approximately 1.8929 for x. All right? Let's try a different one. We're going to solve 2 to the 3x minus 5 equals 16. We take the log of both sides, so we have log 2 to the 3x minus 5 equals log 16. Remember what that log of a power theorem said. We could take that exponent and put it in front and multiply it, can't we? Now we can isolate this by dividing both sides by this log 2. That's going to create a 1, isn't it? Identity property. We don't need to write it. And we get 3x minus 5 equals a quotient of log 16 and log 2. We can get rid of this minus 5 by adding 5 to each side of the equation. Now it's just 3x equals the quotient of log 16 and log 2 plus 5. And we can isolate that x further, can't we? We can divide both sides of this equation by that 3 coefficient. So now we get this big guy here for the right side of the equal sign. Using our calculators, we type in log and then 16, and we get approximately 1.2041, and we type in log and 2, and we get approximately 0.3010. We have to add the 5 and then divide it by 3. Adding the 5, we get 9.003. Dividing it by the 3, we get that x is approximately 3.001. We can plug it back into the original equation for x and find out that it fits. It's just about 2 to the 4th power, which is about 16. Cool, huh? Now there's another way of solving this. There's another method to solve exponential equations, especially if they're compatible. So we've got solve 2 to the 3x minus 5 equals 16. That 2 and that 16 are compatible because that 16 is 2 to the 4th power. That gives us the same base. And because the base 2 is the same on both sides, the exponents must be equal. We can write it like this without the bases. So we have 3x minus 5 equals 4. That's Algebra 1. We can do that, right? We get rid of this negative 5 on each side by adding it, and we get a 9 over here, and we get a 0 here, and we get the 3x. We divide both sides by that coefficient 3, and we get x equals 3. All right? That was easy, right? But it worked because the bases were the same, see? Our next video is 12.7b, and we're going to talk about how to solve logarithmic equations. And links to those 17 previous videos are going to be in this description. I'm going to add this to the Algebra II playlist so that you can use it to study or whatever you need. I want you to remember to try not to skip any steps, okay? You skip steps, you're just going to make it harder on yourself. You can still climb the ladder, but it'll be harder, okay? So I also have this card. Which bridge would be easier to cross? Would you rather cross this bridge or this bridge? I bet you could make it across that one. You wouldn't go as fast as if you just did this one. You could run across that one, couldn't you? So every time you miss a lesson from your teacher or from this playlist, if that's what you're going by, you're making it harder on yourself because you're not filling in all the holes, okay? This, you could go across this without even looking. It would be so easy, right? Because all the steps are there. So do your best to fill in any holes that you have so that it's easier on yourself. You have less stress, all right? I'm really, really proud of anyone who watches math videos on YouTube to help themselves. That's good character. I'm proud of you. And I'll see you next video. We're almost done with Algebra 2. Bye.